Whenever you see the word algebra of something, all it does, it simply means doing these operations. We could add them together, we could subtract them, we could multiply them. In other words, first off, if we had two functions, f plus g, what this means is I can take the two functions, I can either add them together first and then put x in there, or I can take the functions as they are and then combine like terms. Likewise, the next one. I can either take the function equations first, subtract them, and then put my value for x in there, or I can find the values and then subtract the values independently. So f times g of x I can combine them and multiply the answers together. And the last one is the division. As long as g of x does not equal 0. And I'll show you what these mean in a second, because we'll do some of those. And I'll show you how they work. But these are the basic properties of the algebra functions. Example 1. Here's my two functions. The first one I define as x plus 1. And the second function is x square root of x plus 3. So let's look at the first one. Now, what this one tells us is we can add the two functions together. F of x plus g of x. So we have x plus 1, that's f of x, plus square root of x plus 3. And there's the answer. We can't combine anything from there. It's as far as it goes. Now, the next one, this is A, this is B. This one here is going to be a little bit better because this will give us something to compare it and look at it. F plus G of 6 is equal to the same thing as F of 6 plus G of 6. What this one says here on the left side, it means add the two functions together first, which we did that, equals this. X plus 1 plus square root of x plus 3. Once we combine them, then we put 6 in place of x. That's my x value. So I have 6 plus 1 plus 6 plus 3 square root. 6 plus 1 is 7. Square root 6 plus 3 is 9. So we have 7. Square root of 9 is 3, so it equals 10. That's if we do it that way. Very painful. But this side here is a lot easier. It says, let's first take f of 6. Well, f is x plus 1, so it's 6 plus 1 is 7. And g of 6 is square root of 6 plus 3. Square root of 9 is 3. So f of 6 is 7. G of 6 is 3. And together they equal 10. That's the beauty of using, you can use either one you want to. Sometimes it may be easier combining like terms because it may shrink it, but other times it's just take the values, then plug them in there. Okay, using the same f and g, let's put -4 inside there. So we have f plus g of -4. Remember, f of x is x plus 1. G of x is square root of x plus 3. So what this says, it could be f of -4 plus g of -4. So we take this one first. We have x plus 1, that's f, plus g, which is x plus 3, of -4. So anywhere I see an x, I put a -4. -4 plus 1, 4 is bigger, the answer is negative. 4 minus 1 is 3. -4 plus 3, 4 is bigger, the answer is negative. 4 minus 3 is 1. Square root of -1 is I, but we haven't talked about that yet. So no solution. No real solution. Because you cannot take a square root of a -1. Remember, square root of 4 equals 2 or -2. Why? Because 2 times 2 equals 4, and -2 times -2 equals 4. You cannot do that same thing if the number inside there is negative, because they have to be the same numbers. There are no two numbers multiplied that give you a negative answer. So let's just say no real solution. So we can't go any further with that. The domains of f plus g, f minus g, f times g, and f divided by g. Whenever you have these two types of functions, two functions together, the domains are the intersection of the domains of f and g. Okay, what does that mean? So if f of x was x plus 1 and g of x was square root of x plus 3, what's the domain of this one? In other words, when we say what's the domain, it's what x values are legal. Which ones can fit in there without ruining anything? For other words, not making a negative inside the square root, or dividing, put a 0 on the bottom of a fraction. So in this one, it's a linear equation. So the domain is from -infinity to +infinity. The domain of this one, well, the rule about square roots, a square root can have, you can take a square root of 0, square root of 0 is 0, square root of a positive number is an answer. you cannot have a negative number in there. So the domain is from 0 to infinity. So what this thing says, here's my f, this is my g, this is my f plus g. When it says the intersection of the two domains, so for the f, we go from negative infinity to positive infinity. G, we go from 0 to positive infinity. So where do they overlap? They overlap from 0 all the way to positive infinity. So that's my domain of that function. So that's the domain of f plus g. F plus g, f minus g, f times g. These three all have the same domains, the same way. The only one that has it different is the bottom, is the f divided by g. Because this last one, we have this plus g cannot equal 0. So anything that makes the bottom equal 0, so it's like for here, since g's on the bottom, we couldn't use 0. So the domain couldn't be this. Our domain would be from just over 0 to infinity, even though the rest of these are this. So that's what look at your functions, find the domains of them, and then see where they overlap. When we finish these sections here, we'll go over all the functions, and I'll show you what I'm talking about when we talk about domains and ranges and things, and the functions themselves. All right, so let's look at example 2. So f of x is equal to x squared minus 4, and g of x is x plus 2. Find the domain of f plus g, f minus g, f times g, and f divided by g. So remember, these three here have the same domain. So let's look at f of x. Are there any x values we can put in there that makes it undefined? No. X can be negative, x can be 0, and x can be positive. So the domain of this function is from negative infinity to positive infinity. And the g of x function, x plus 2, it's a linear equation. X can be negative, x can be 0, and x can be positive. So this one is also from negative infinity to positive infinity. So the domains of all those, where they intersect, they both go from negative infinity to positive infinity, so that's the domains of all of them. Except this one. Because since g of x goes from negative infinity to positive infinity, it can also equal 0. In other words, x plus 2 equals 0 when x is negative 2. Because we cannot have 0 on the bottom, x cannot equal negative 2, because it'll make it equal 0. So the domain of this function is from negative infinity to negative 2. union -2 to positive infinity. Because whenever you have a fraction, you have to see what makes the bottom equal 0, and you cannot use that one. That's A. B. F plus G of X. Remember, that's the same thing as F of X plus G of X. There's F and G. So what we have here is X squared minus 4 plus X plus 2. Combine like terms. There's X squared. There's an X. -4 plus 2 is -2. So there's that equation. That is the function. I added the two together. F minus G of X, which is F of X minus G of X. F of X was X squared minus 4 minus X plus 2. Problem. Whenever there's a minus between there, you see all this thing did used to be X plus 2. All it changes is negative. We have to put these numbers in parentheses. Because this whole equation is after the negative, it goes in parentheses. Because we have to distribute that negative. So combine like terms, we have X squared minus X, -4, -2, they're both negative, so we add them, and there's that answer. F times G of X is F of X times G of X, which is X squared minus 4 times X plus 2. Distributivity, we have to multiply those together. So everything in this first parenthesis multiplies to everything in the second. X squared times X. There's two X's there, multiplied by another one, so it's X cubed. Positive times positive is positive. X squared times 2 is 2x squared. That does it for that one. Both of those. Now the -4. Negative times positive is negative. 4 times x is 4x. Negative times positive is negative. 4 times 2 is 8. And nothing else can be combined. So there's my answer. And we'll be using this kind of stuff the rest of the semester. So we gotta start practicing up on that. Then we have f divided by g of x, which is f of x minus g of x. F of x is x squared minus 4, and g of x is x plus 2. We haven't talked about this. This comes in the next chapter, which is what I really hate about this author because they do this. Because this is a square, the degree is 2. It means we have two answers, which means I can break it up into two pieces. The bottom one is just what it is. What this is called on top, 4 is made up of 2 times 2. So it's x squared minus 2 times 2 is 2 squared. This is what's called the difference of two squares. Whenever you have two terms that are perfect squares and there's a minus between them, we can break them up. Take the numbers that are on the bottom, x and 2, x and 2, and put opposite signs between there. That's called factoring, which we'll do tons of that in chapter 3 and 4. So whenever you have a minus between two terms, and the first term is squared, and the second term is a perfect square, in other words, if it's a 4, a 1, because 1 is made up of 1 times 1, if it's a 25 or a 36, if I can have perfect squares, then whatever's in the bottom below the squares go inside the places, and I change the signs. So this one is x plus 2, x minus 2. So the x plus 2's cancel, which leaves me with x minus 2, and that's my answer. The last one is g times g of x, which means g of x times g of x. G is x plus 2. G is x plus 2. So everything in the first parenthesis multiplies everything in the second. So x times x is x squared. Positive times positive is positive. X times 2 is 2x. Positive times positive is positive. 2 times x is 2x. Positive times positive is positive. 2 times 2 is 4. Combined like terms. X squared. These two terms are the same. They both have x's. 2x plus 2x is 4x plus 4. And there's that answer. All right. Now we're actually doing pretty good. The symmetry really shouldn't take us that long. Oh well, we'll see. The next part, something called the difference quotient. The difference quotient is the same thing we did earlier. The difference quotient finds the slope. Of a line tangent to a curve. We're not going to go that far. We're going to leave it as a secant. What does that mean? If you have a curve and you have 2 points, this is 1 point, and here's another point. If you connect those 2 dots, we could find the slope of that line. This line is called a secant line because it goes through the curve at 2 points. It looks familiar because that's exactly how we found the slope the first time. Remember, it was y2 minus y1 over x2 minus x1. So what we have to look at here now is what we're going to do. This is the secant line. What we want to know what is the slope of that line at that point there. That's called the tangent line. The tangent only touches the curve at one point. The secant needs 2 points. The tangent only needs 1 point. So we have to go from this. This is the secant line. We have to go to an equation that deals with a tangent only. Let's see how we do that. So using function notation, y2 is the y value from the second point, which is f of x2. This is x1. This is x2. This is f of x2. This is f of x1. So y2 is the second point minus f of x1. That's the first point. x2 minus x1. In order to have a tangent one, we have to get rid of the second x value. How do we do that? Well, basically is what's happening is we want our values, we want this value here to get closer and closer and closer to that one. So right now, if it's here, let's put it over here. We have another slope, then another one here. It's getting smaller and smaller. Eventually, as these values get closer, this one disappears. It becomes x1 only. That's our goal. So how do we do that? How do we go from point x1 to point x2? We'll call that distance h. So if you start off from x1 and you add whatever h is, you'll end at x2. So in other words, if this was 5 and h was 3, 5 plus 3, that means this one's 8. So now we have a new way of defining x2. Anywhere we see an x2, we put an x1 plus h. So x1 plus h minus x1. On top, we have f of x1 plus h minus f of x1. On the bottom, x1 minus x1, x1 cancels. So now we have our equation for what's called the difference quotient. The difference quotient is this. This is the slope of the line tangent to the curve at one point. Because we only have one x value, and eventually h will go away. Remember, this equation is the slope of the function. Let's look at it. Let's look at how to do these. Example 3. F of x is equal to 2x minus 3. Let's start off slow. Find and simplify the difference quotient. Remember, the difference quotient was f of x plus h minus f of x over h. That's the difference quotient. Okay, so in order for that, we have f of x. That's check. That's check. We don't have f of x plus h. So we have to find an f of x plus h. We have to create it, actually. So if that's f of x, What now, anywhere you see an x, we put an x plus h. So instead of 2x minus 3, it's now 2x plus h minus 3. Now we have both of the values we need. So the first part, we have f of x plus h, which is this, 2x plus h minus 3 minus, that's that minus sign, f of x. F of x is the original function. Now, because it's after a minus, it has to be inside parentheses over h. Because there's a minus sign between there, this function here, put it in parentheses, because if not, it'll only change the first term. Here's a general rule. When we finish simplifying, everything after this minus sign, all these terms here, have to cancel. They have to cancel, or else we did something wrong. So let's figure this out. Get rid of the parentheses. So we have 2x plus 2h minus 3. This negative distributes inside there, so it's negative to positive is negative 2x. Negative times negative is positive. All the parentheses are gone, so the next step is combine like terms. The 2x and the negative 2x cancel. The negative 3 and the positive 3 cancel. So all we have left is 2h over h. The h's cancel. And we see the slope is 2. Well, we knew that. Because if we look back at the original function, it's a linear equation. Remember, y equals mx plus b? This was the slope. We figured that out. So we know it works. We know it works. Now we have to use it in different functions. Let's use it for different functions. It works for rational functions also. Remember, we have to use a difference quotient, which is f of x plus h minus f of x over h. So we have f of x, that's this one. Then we need f of x plus h. All that means is anywhere we see an x in the first equation, we put an x plus h. Now we have both those functions, so now we can find the difference quotient. So f of x plus h is this one. So it's x plus h under 1 minus 1 over x. So that's f of x plus h minus f of x all over h. Okay, so we have to fix the top first. Whenever you subtract fractions, you have to have a common denominator. This one just has an x. This one has a whole equation. So this one needs an x over x. This has an x plus h. This one doesn't. So this one needs an x plus h over x plus h. So my common denominator is x plus h. X times 1 is x minus 1 times x plus h is x plus h. All this over h. So x times 1 is x. 1 times x plus h is 1x. Put in parentheses. H is on the bottom. The denominator is x plus h. Let's get rid of the parentheses on top. Leave the denominator alone. Don't do anything with that. If anything cancels, we'll do it later on. Right now we're doing the top. So we have x, distribute that negative sign, so it's negative x, negative h. Combine like terms, so the x minus x cancels. So we have negative h on top, x plus h on the bottom, all that divided by h. Now we have a fraction on top, we have a fraction on the bottom. This is h over 1. Whenever you have a fraction over a fraction, it's called a compound fraction. Whenever you're a fraction on top and bottom, take the top fraction and leave it alone, multiply by the flip of the bottom. So that's what you see here. So we have on top, we have negative h over x plus h, and flip the bottom. So it's 1 over h. Anything on, since they're multiplied, anything on top cancel with anything at the bottom? Yes. H goes in h 1 time. So it's negative 1 times 1 is negative 1 on top, x plus h. We're not done yet. Because remember, the whole purpose of this thing is to get rid of that x2 thing. Because you only have one x value. So remember what I said here. We want x2 to get closer and closer and closer over here. That's what h is. H is the distance between here. As x gets closer, h gets smaller. Eventually, it goes to 0. When h goes to 0, x1 equals x2. That's when they're the same value. So what we have to do here, anywhere we see an h, make it go to 0. So you have a negative 1, h times x times x is x squared. That is your slope. No matter what x you give me, it's always going to be this equation. Why is it negative? Remember, this is a slope. Why is it a negative slope? Well, because look, if we look at the function itself, and that's what we're going to do next. I have to do one more example. We're going to see that the function 1 over x is always a decreasing function. So that's the proof of why it's a decreasing function at all points. All right, we have one more example here. And then we'll go to the library of functions. F of x equals 2x squared minus x minus 3. Use the difference quotient, which is f of x plus h minus f of x over h. So we have f of x, check. We need f of x plus h. for this first part. So anywhere we see an x, we put an x plus h. Yes, and put them in parentheses because, like this one here, it has to be squared. This one here is after a minus sign. So now we can start plugging things in. F of x plus h is this. 2x plus h squared minus x plus h minus 3. That's this first part. Minus f of x, which is 2x squared minus x minus 3 all over h. Remember, all of these eventually have to disappear. These get messy really quick, but then they clear up pretty quick also. So for the first one, we have to do the x plus h squared first. We have to do that one, which is x plus h, x plus h. X times x is x squared. X times h is plus xh. H times x is xh. H times h is h squared, and they're all pluses. So this one becomes x squared plus 2xh plus h squared. 2xh plus h squared minus x plus h. 2x squared minus x minus 3. So we expanded the x plus h squared. That became this equation. Now we get rid of the parentheses. So 2 times x squared is 2x squared. They're all positives here. The first one's positive, positive is a positive. 2 times 2 is 4xh. Positive, positive is a positive. 2 times h squared is 2h squared. I get rid of the first parentheses. Negative changes both of those signs, so it's negative x minus h minus 3. And this negative changes everything, so it's minus 2x squared. Negative and negative makes it a positive x. Negative and negative makes it a positive 3. So we got rid of all the parentheses, now combine like terms. So the 2x squared, negative 2x squared cancel. Negative x, positive x cancel. Positive 3, negative 3 cancel. Remember, everything back here has to cancel. That's what I use as a basis. So it's 4xh plus 2h squared minus h over h. On top, they all have at least one h in common. So we can factor out one h, which means I have 4x plus, I took away one of those h's, so it's 2h. I took away that h, so it's a 1. Now, as a general review, because I factored out the h, to see what goes inside the parentheses, I take this numerator and I divide each one by what I factored out. Whatever's left goes inside here. So h cancels, so I have 4x plus 2. I took away one h, so it's 2h. h divided by h is 1. That's where I got this stuff here. The h's cancel. Now my slope of the line tangent at any x value is that. That's my slope anywhere on the curve. All right, and this is the end of section 2. Any questions? All right, let's go over first and talk about the